Well, welcome back. I think everybody here has been to at least one crash course, so good to see familiar faces. This is the third session of our crash course on creating LED matrix that's scalable using sublayouts. Just a quick overview. We're going to recap what we covered in session 2, actually not session 1. We're going to have a demo and spend the majority of the time doing that, and then take some questions, hang out, maybe break open our some beer, some kegerator, celebrate our Friday. So just a reminder, our course goal here is building this LED matrix that's scalable using sublayouts, and people have built their own projects. Obviously, there's 2 different paths. We had a reference design that you can follow. So, as Gerber completes these demos, he's been sharing that Flux document that you can fork and use as a design reference, or, literally build on top of that. And then the second path here is designing your own PCB. But cool. I think we already covered this. This is what we covered in session 2. We learned how to use portals, which are pretty much like net labels to clean up our schematic diagram for the LED matrix, the 4x4. And then we actually routed that 16 LED matrix and turned it into a sub layout. And again, sub layouts are like reusable blocks that you can use in other circuits. So you don't have to redo a bunch of work if you want to recycle a portion of a PCB that you've already routed and positioned components on and whatnot. So today we are going to use the sub layouts that we created during the last session to create a larger 8x8 matrix. And we're also going to show you how to import a 3D enclosure and just how to deal with 3D assets generally, which I think is pretty cool because, I think it can tighten the iterative loop between electrical engineering and doing other PCB work and mechanical engineering, making sure that things fit and line up, working with mechanical engineers, whatnot. So that's cool. And then the second thing we're going to learn is, we're just going to talk about how to export, create the Gerbers and export them, and kind of make sure that you've checked all the boxes, preparing your project for manufacturing. And for those who are interested, we can even walk through the steps of like how to upload a project to, JLC PCB or something like that. If you haven't had that experience yet, we're happy to do that. And yeah, that's it. With that, I'll just hand it over to Jarwin for the demo.
Yeah, sure, Lance. Let me share my screen here. Portion of my screen.
Yeah, as always, feel free to interrupt us or use the chat. Using the chat is probably a little bit easier to manage if you have questions.
Okay, so can you see my screen, guys, here?
Yep.
Yeah. So yeah, Lance already mentioned all of the the recap that we have done in the last session, but this project here is actually like this, the entirety of this. So in the last session we just covered the first quadrant here, the 16 LEDs. So we're going to multiply that one 4 times to build this 64 8x8, 64 LEDs, and then a couple of primitives component here. I'll be using a tantalum for this polarized capacitor, and then the rest is like 0805 resistor, and the max 7219. And this one here are like the termination point, because basically you can DC chain this 8x8 LED matrix. If you want to go crazy, you could build actually like a huge TV monitor. So I already done the the wiring here and the schematic, because it would take us a lot of time to actually you guys watching me and going to wire this one. It would take a lot of time, but I just want to point out some of the components here. So this is the Max 7219, the main IC of this LED metrics. And this one here, you see this 4 SL1, 2, 3, 4. These are the sub layout that we have created in the last session. If you remember the termination point, yeah, they are here. And then, yeah, and also like these terminals here are the termination point later on where you connect this pad when you daisy chain. Okay, so we'll just focus on the PCB side. So I'm going to go to the PCB now, and okay, it looks a little bit messy because by default that is the size of the layout. So the first thing that I'm going to do is to resize the board. So I'm going to select that element on the object tree panel here on the left side. So I'm going to select the layout because that's the board, and I'm going to add the size rule, and then I know already the size of this board that I'm going to build because I already designed the 3D model of this LED metrics. You could see it later on, how it plays out in here. So we're going to resize the board. So this should be 32 millimeter by 32 millimeters. So instead of typing in 32 space 32, yeah, you can actually just put 32 and that automatically like considered X and Y. Okay, I'm going to reposition the component now. And by the way, so I already, take the first hand to actually like route this board, and it's impossible to route this using just 2-layer. So if you look at here on the layer view controller, by default, if you create a project in Flux, it's always 4-layer. So I'm not going to add any stack up configuration here to configure my layer. So if you'll be working on just a 2-layer board, yeah, you just need to call the stack up and then select from the drop down later on if it's like 2-layer, 4-layer, or 8. So for now, I'm just going to keep it like by default 4-layer, as you can see here. Okay, and then the next thing that I'm going to do, I'm going to hide this grid here for me to see literally everything here. So if you look at the components folder, it contains all of the components, the pads, and then the sub layouts here. So this one is the sub layout that is like the 4x4 that we created on the previous session. So I'm going to move them here inside the board. Okay, so I'm going to just drag this U1 somewhere here, and I'm just going to focus on making sure that these sub layouts here are like under each quadrant. So this one is the sub layout 1, and then where's the here sub layout 2? Okay, it's here. Just going to eyeball this, and then sub layout 3 is here. Okay, should be here. And also, as you can see, I created a global selector rule, which is like here, the out pad and the end pad. That's actually the rules that drive this termination pad in here. Okay, so I'm just going to make sure that there would be no via that will going to interrupt that pad in here. And I guess we're good here. Okay. And then going to drag the other sub layout, the sub layout number 4. Should be here. Should be this one. Going to just drag it in here. Okay. And yeah, I want the other components. The Max 7219, the resistor, the capacitor to be at the bottom. Okay, because my plan would be like, I want to enclose the entire 64 LEDs using like, a honeycomb kind of holes. You will see it later on. So, okay. But first, Let me hide the paste and the mask so that I could see the blue copper indicated by the blue. It's like the bottom. Red should be the top copper. Okay. Going to, okay, so this one should be at the bottom. So I'm going to select them all and then set it to the bottom layer. So how to do that is actually select the C1, C2, wait, it should be control, command, R1 and U1. And then going to right click and flip, because yeah, basically flipping the component, you know, it will be set to be like at the bottom copper already. So sometimes the app is like slow. So yeah, takes a couple of seconds. And then you can see here, they're already in blue. That means they are on the bottom copper. Okay, so I'm going to just hide the air wires for me to see clearly, you know, or maybe like the top copper also. Okay, and then maybe the top overlay, because I want to avoid this blue, what do you call that one? Blue copper. Okay, going to put them here. Okay, and then the rest would be like, you're just going to follow. Oh, let's just wait for this one. Oh, wow. Okay, yeah, Google Chrome, I'm going to wait, no worries. Right, okay, so here, R1, going to drag it in here. Or maybe I need to turn on the airwire for me to see where they should be connected later on. Okay, so this one should be somewhere here. And yeah, C1 should be here. Yeah. And yeah, I'm going to just rotate this C2 here. So rotate, what is that? Left? Yeah, left. Then I'm going to drag it in here. Okay. Then yeah, I think I'm good with that. I'm going to just activate the layers that is like top overlay and then the top copper. And then guess what? We are like a massive airways here, which is like, yeah, very normal. Every time you create a PCB, you know, this is like how you manage your, you know, your initial thinking, how you're going to position each of the component, everything that is like, yeah, this is the first process. But yeah, we could actually like route some of the pads in here, but again, that would consume a lot of time, and we already have covered, you know, in the last couple of sessions, how to route this board. You know, it's almost similar to, yeah, to the schematic diagram. Click on the dot, you know, then it will create the airwire right away. And just to make sure, this airwire or this route should be connected in there and here. Okay, so I could actually just reach here and then, oh, what is that? Why is it I cannot click? Okay, one more time. Click here. Okay, and then here. Yeah. Oh, it created some random traces here. But yeah, we're going to save time in here. So backup project, completed the traces, because we're going to focus on what we need to learn on this session. So yeah, this is how it looks like when the board, or I mean, everything is like routed all together. And yeah, definitely somebody are going to say, this is not yet completed. I could still see a couple of errors here, 1, 2, 3. Yeah, that is the ground pads. You know, I intentionally did not trace that one because maybe like the next couple of weeks we will have the cover fill. I'm not sure, when that would be landed, but yeah, it's already in work in progress. So once that landed, I just going to visit this project, again, and those pad that is like connected here to there. I mean, if we could actually activate and deactivate the airwire, we could see where are those in here. Okay, so yeah, we're just going to leave that one, not connected as of the moment. So yeah, I'm going to just leave it in here. So yeah, let's imagine this one is already done. You already routed everything. So as you can see, it's a 4-layer board. Red indicates top copper, mid layer 1 indicated by the yellow copper line in here, the mid layer 2 indicated by the cyan blue, and then the bottom copper is like, I guess that is like, darker blue. So yeah, I'm going to focus here is how to insert your 3D enclosure, So if we take a look at the 3D view of this board, we're going to see that all of the LEDs are on the top. Let's wait for this one. Yeah, I'm going to turn off the grid again so that we could pay attention what we are looking here. So as you can see, all of the LEDs are on the top, and then at the bottom, yeah, the components, right? So I created what do you call this one? Yeah, a 3D enclosure, something like that I want to put in here so I could make some decision if, yeah, this is looking good, etc. Right? So what I'm going to do is I'm going to, oh, by the way, it's already added it in here. The 3D files are already in here, but yeah, it's basically like clicking the manage and then adding an item, and yeah, just searching for that file on your local computer, and that's it. And as you can see here, every time you upload an asset, there will be an ID. You see this one, the ID, you could name that one to anything you want, like this one also, so that when you create a model node, you know what the asset you're going to call, okay? So yeah, let's start. Going to add here, going to click on the root, and I'm going to right click and then click model. That basically create a model node that is like, oh, why is it taking so long? Yeah, it would create a model, as you can see here. It's blank. There's no rules that is like attached to it. So we need to call the asset. Just call the asset, then add. Then once it's added, you're going to see two options here. Because you added two assets, there will be two drop down here. As you can see, there's two here. I'm going to select the first one here because I know that this one is like the top enclosure. Okay, I'm going to just click on that, and we're going to see that it would appear in here later on, or I guess it will not, because when I designed this 3D model, I was using meter as my unit, and by default in Flux it's set to millimeter, so I need to scale this one. Okay, I'm going to call the scale, and because I need to scale it down to 1,000, I'm going to modify 1 into 0.01. See that? This is the 3D model that I designed on Tinkercad. So it's not perfectly aligned yet, as we can see. This one should be flash all around the edges. Okay, so I'm going to add another position rule to control the position. Add position, and then I'm going to, I guess the position with this B will be like 0, -6. Oh yeah, pretty much like familiar. Yeah, so it's much flash to all of the corners. As you can see that. And then as you can see, it looks like metal, right? It looks like metal because Flux, if Flux didn't actually like, I am not sure how could I explain this one, but there's a default texture material in Flux that every time you add a model, sometimes it cannot figure out if that's a plastic, that's a metal, or whatever. So I'm going to add another rule again that will actually disable that texturing kind of uh, whatever override Flux is doing. So I'm going to add physical material, okay, and I'm going to set it to false. And I'm sure there's a bug in here that after disabling the physical material, the model still looks like metal. Okay, so I'm going to just refresh my browser. Yeah, I found this bug before the event that started. So the model should look like a green plastic. It's a 3D printed, you can 3D printed it, or you can actually get it manufactured to, some fabricator. But yeah, it looks like this, as you can see. And yeah, that is how you control or set the 3D model, together with your project. So you could actually like decide if if the enclosure is like will fit on the board, or I mean if that enclosure or I mean that will fit to the enclosure. Yeah, that's how you do it. And as you can see, uh as we mentioned, this project is scalable, right? So imagine if you have multiple of this board line up together, it would look like this. Okay, we could play around with the model in here. So I'm going to just copy, okay, and then click the root, and then I'm going to just paste it in here so that we will have two model node that has the same rules, the same asset. And I'm going to show you why is it that there's like, you see those the each corner here, they have like, okay, so I'm going to just set this one. I guess 32.1 by -6. Okay, see that? I'm going to add another, rule here, the Z position, so that I could Z, literally the vertical, lateral, vertical movement of an object. So right now it's set to 0. Okay, we're going to see how this one will play out. If I'm going to set this one like maybe like 1 millimeter or something. Yeah, or maybe that's not yet. So okay, maybe like let me try it again. Maybe instead of 1, maybe 2. And as you can see, it will lock together. So I'm sure you get my point here. If you have a lot of these, manufactured and they are aligned, yeah, you can actually like put them together so that they are locked in place with this particular, holes in there. So yeah, so there's a question in here from Travis Bowman. Thanks, Lance. What format does Flux accept? So if you go to the schematic editor or something, or maybe yeah, just click on the canvas. You can see the asset panel, right? The answer to that question relies to this model in here. So when you upload an asset, you're going to see here what are the supported formats. As you can see here, for symbol, yeah, it's SVG. For 3D model, it will accept .glb, .dxep, .step, .stp, so on and so forth. Yeah, but so far, I guess these are the things that we already have tested in terms of the 3D format. GLB, and yeah, I guess the most efficient one is like that step. Yeah, it contains the texture already, but sometimes the GLB, it's missing some of the properties of a 3D model. So yeah, I hope that answered the question, Travis. So yeah, that's how we're going to do it. So maybe you're asking, there's two 3D model in here. One is like green and the other one is like this. Okay, I just actually intentionally add that asset so that I could add another model in here, because yeah, maybe you're asking, oh, this is just a hole. So if that is the LED, how could you diffuse the light? Okay, so my plan on this is like 3D printed this 3D model and then just pour a liquid diffuser, an acrylic liquid diffuser. Okay, so what we're going to do is I just created the new model. Going to rename this one to something else like, liquid diffuser, so that I could differentiate them here on the on the left panel in here. Going to add an asset again, and I'm going to call that liquid diffuser here. Then I'm going to add scale because I designed the 3D model in meter unit. So I'm going to set it 0, 0, 1. Okay, this one will be fast. Okay, and then maybe it's Z position. Should be 0. Oh, the asset just disappear. Okay, liquid diffuser. Okay, that's it. Okay, I'm going to position this one. I guess it should be a -6. There's an offset that I need to figure out in here. 0, -6. And as you can see, this one should be white. Should be white. It's a diffuser. The thing that you actually like, mix together, and after you pouring it on the hole, it will, it will turn very solid, and it will just diffuse the light. Okay, so I could actually set this one to 0, -6, and the Z will be like, let me try to play around with this one, -1. Yeah, something like that. It would look like that, but it should be white, not metal. But yeah, I guess you already get the point in here. I just want to diffuse the light so that it would be, it would be smooth when it will light every holes in here. So yeah, I guess that is like more about the, how you could actually, what do you call this one? Introduce the mechanical side of your project in Flux. They are already in here. It's just that you need to actually like design the 3D model on another third-party tool. But yeah, in terms of, verification, etc. For example, you have a huge capacitor. You're not sure if that capacitor will block the enclosure or something. Yeah, you can already decide in here once you import the model. So yeah, I just actually like put the other model in here for just playing around and to make sure that I could explain clearly this this locking mechanism in here. So yeah, let's say for example you have a lot of models in here. Maybe like your project is like very complex, and you want some of the model to be like hidden. Just hide them. I don't want to see it for now. Something like that. There's a quick trick that I could share to you. There's an enabled rule. Okay, just enabled rule. Just add that, and then just because I just added that enabled rule on this model here, I'm going to just make it false, and it will just disappear on the canvas. As you can see, it disappear, as well as here. It's grayed out, as you can see. And then yeah, later on you could actually activate it again if you want to see it, everything. I mean the entirety of your project. So yeah, enabled false, and that will hide it. So yeah, and yeah, I guess we're good on that in terms of the importing of the 3D model, to preview it here on Flux. The next thing that we need, I'm going to demo in here is like how to export the Gerber from Flux. Okay, so that you can get it manufactured. Let's go back to the 2D view, and let's just take a look again on the traces. Okay, and just disregard the extra airware again because those are the ground nets. Okay, so to export the Gerber in Flux, once you are done, you just actually just click in here, go to the export, and click here, Gerber RS274X2. It will vary in just a couple of seconds. You're here. I got it already in here on my local computer. So in terms of the Gerber, so maybe some of you is not aware about what is a Gerber. So let me just open my Finder in here, and we could take a look at that zip file that we just downloaded. So Gerber is actually just a zip file, okay, that contains all of the layers in terms of physical layers. So I'm going to just uncompress this, and you can see in here. And I'm going to just put this one as a list view. So as you can see here, I just unzip the zip file, and it contains all of the .gbr files. And also in Flux, you don't need to export separately the drill file, which is like the drill location of the via, location of anything that is like it needs a drill, it's already in here, packaged all in one. And as we can see here, maybe some of you are not aware what are these, basically this indicate, like, let's say for example this one F_CU, that means to say front copper. B_CU means bottom copper. And as you can see here, there's another one in here, in 1 and 2. This is definitely the inner copper layers, and the rest are like very, very obvious already. Mass for the back, paste for the back, and so on and so forth. So we cannot get a decision in here, if it's good, if this is good, or if we did something like that, or in terms of verification on the exported Gerber from Flux, we could actually use another web app in here so that we could verify if the traces that we have created, it's exactly look the same. So I'm going to share you this link here. It's called tracespace.io view. Okay, I'm just going to drag and drop that zip file in here, and as you can see, there is the PCB board. Does it look like you can see everything? Because we are looking at the top. This one is the bottom. Okay, if you want to go inner and take a look at all of the layers, just click here on the layers, and you could see something like each layer are opacitated. Okay, so we could actually like hide the mask and paste so that we could literally see the top copper. See, you could actually like hide this area in here, and you could see okay, that those are the top copper, these are the bottom copper, and this one here, the yellow, is the inner copper, the first mid layer one, and the next one here is the middle. And yeah, basically it's almost everything in here. Silk screen, yeah, these are the printed uh printed information on the top of the board in terms of the top, because we are here on the top. This here is the bottom, so I'm going to turn that off, and guess what? We're just ended up with drills. You can see those are the drill holes for the via. So I'm going to activate them again so that you guys could see. So as you can guys, looks like perfectly the same. If we could put this one side by side. Okay, thank God I shared my screen, using area portion so that we could compare. Let me drag this one in here. And by the way, if you want to just pay attention to the board without looking at if you are not, you don't concern about the left panel and the right panel, there's a trick that I could share again in here. Just go to the view and select here, hide and show UI. And that basically just, hide everything, and you ended up with just the board. So yeah, we could actually like look side by side. And for me, yeah, I already validated this one a couple of hours ago, and yeah, this one looks okay. I mean, perfectly same. So yeah, let's say you're good enough. Okay, pretty much like I'm competent enough. Okay, let's get this one manufactured. Okay, so I'm going to close this one in here just for me to save some GPU memory. Okay, so I'm going to I'm going to open oh my God, my Chrome just crashed. Restore. Okay, let's open GLPCB. Don't need an account to test anything in here. You just go to GLPCB, and as you can see here at the very top, And by the way, why is it that, GLPCB? Because this is the fastest, PCB board manufacturer that can give you like at least 4 days, and you already have like the board, and they are the cheapest. They're located in China. So yeah, US, Canada, it's the same, 5 days, So I'm going to look for that exported Gerber again, the zip file. I'm going to just drag it in here on this area. Okay, drag it in here, and then it will load their system, and it will show you the preview of the board. Basically, as you can see here, yeah, that is the top portion of my board. This is the bottom, and as you can see, their system automatically is smart enough to identify, yeah, this board contains 4 layer. It is 32 by 32, and yeah, the minimum PCB quantity is 5. And everything here, you can, take a look. Oh, I want like the purple or whatever board you want, but this is the important thing in here. Okay, the layer stack up. You need to tell them what is the top copper, what is the inner layer, blah blah blah, until to the bottom layer. So for me, I could just click on the select, and yeah, front or top copper are the same. So here, front copper. This one is the BCU. That means bottom copper, and inner 1 and inner 2. Oh no, inner 2. Where's that? Yeah, here. So yeah, and then yeah, you just need to save to cart, and you can also see that it will, I guess it's like $2 for 5 boards, and the shipping is like 18. So believe it or not, the shipping is much more pricier than the PCB itself. So yeah, I guess that is like everything. And also, yeah, they also offer like PCB assembly. So if you toggle this one on, you could tell them, okay, I want you guys to solder the board for me. And then you just send it over to me already soldered everything, just need to power on the board. So yeah, they offer the service, PCB assembly. And this particular service from GLPCB, it requires the bill of material as well as the pick and place. So we in Flux, all of those files are here. I mean, if you go here on the Flux drop down menu, go to the export, and as you can see, all of the things that the GLPCB require for the assembly service is already here. The bill of material and the pick and place. Basically, the pick and place will just actually like just a spreadsheet that contains, the rotation, the exact location of a certain component. Let's say, for example, the what do you call that one, the Max 7219, the U1. Yeah, where is the centroid of that component, where it's located, how it's where it's located, how it's rotated, so that the robot could actually, yeah, it's a robot that actually solder everything. And yeah, you just have to decide which side, top side or bottom side or both. And yeah, everything will be like, it's much more pricier because yeah, they're going to also provide the component, as long as you indicate everything, what is R1, what is the manufacturer number of that, everything are like, it's already in Flux here. Flux provide all of the things that you need by far in terms of the manufacturing. So okay, I guess that's it. Or somebody else have a question here?
It's like Alex just had a comment. There are other shipping options, but the cheapest may not ship to you, but their ordering system doesn't tell you. So it sounds like a little gotcha.
Yeah, I one of the things that I ordered, I didn't care about the time, so I selected the least expensive option, but they didn't ship to my address, and I got an email from JLCPCB to say, oh yeah, we can't ship to you. Can you pick something else? And I had to ask them, hey, who does ship to me? Because even when they told me like to pick somebody else, they didn't tell me who would. So they had to send me, it took a couple days of communication to figure that one out. And it was a couple days because of time difference. They're I think it's early morning there now.
Yeah,
Yeah.
yeah. I've noticed like they're pretty responsive with their customer service and like troubleshooting and whatnot. But yeah, sometimes a little bit of a delay. We got a question from Dave saying, maybe I missed this, but is there a way to simulate the operation of the board to see it work, i.e., or they're making sure there's no shorts or missing connections before you send it out for manufacturing? So it's like, DRC capabilities. So everyone take that on?
I'm not sure I followed the question. Can you repeat, Lance? I also don't see it on the chat.
It was a direct message. This is Dave
Okay.
saying, are there DRCs, make sure there's no shorts or missing connections before you send it out?
Yeah, so we don't have DRCs just yet, but yeah, definitely something that's on our roadmap for implementing. The DRC, just for context for everybody that might not know that, is designed will check. So it's basically a list of checks that the tool will run to make sure that your PCB is designed according to your specifications. These type of rules work slightly different in Flux. We have many of them that are done live. For example, the track width and all that, like the tool won't let you mess those up. For example, if you set up a minimum trace width, the tool won't let you put anything less than that minimum. So some of those do not won't make sense or won't be needed, let's say. But some others, like there's no unrouted nets or things like that. Yeah, the stuff that we'll need to that we'll provide when we implement the DRC. But just for you to be aware again, the idea of Flux is that the DRCs that we're gonna need are gonna be substantially less than any other tool, because most rules will get implemented live, let's say, or real time. That's to say that you won't be able to not abide by those rules. The tool just won't let you do that. I don't know if that answered the question. Let me know if there's anything that I haven't covered.
It made sense.
Yeah, just to add up to what Nicholas have mentioned, I created a template which, everyone could actually like a fork, and that will set like, as you can see here on my profile, every time I'm going to create a project, there's a template that I could select, 2-layer GLPCB constraint. That means to say, if I'm going to create a project and that is like just 2-layer board, I'm just going to create a project from template and select that in here. And as you can see, I just did that one. And if you take a look at the rules on the PCB, all of the things that, pertaining to the GLPCB manufacturer, these are already in here. Like, for example, the minimum trace width is like 5 mil, 10 mil, etc. And I mean, board color, yeah, it's not really that needed, but the via hole in the diameter is like, they're specifically strict on that, because if you go smaller than that, they're going to request much more, higher price. But in terms of the DRC, like for example, crossing traces, etc., we haven't that, but yeah, there's a work in progress from the Brookside, from the product design team. But yeah, in terms of the manufacturing, all of those things, they are in here. The solder mask expansion, what is the needed, what is like required by GLPCB, it's already in here. So if you're going to start a project, you don't need to think about all of these constraints again. Yeah, I'm not sure if that that will add the answer to the question.
Yes, thank you.
Yeah, definitely we need something like a check if there's like a crossing trace, because yeah, I honestly say I've done that before.
Any other questions? And they don't have to be related just to the LED matrix project. It can be your own projects or anything generally. Bless you.
Thank you.
Was anybody able to follow along and maybe they got stuck or had a question with the demo from last week? Cool, cool.
I need to retrace mine.
Okay. Why do you need to retrace?
I didn't when I traced out the initial grid. I didn't keep the bottom copper traces off to the side like Jarwin did. And so now there's no space on the bottom of the board for anything because it's just a whole bunch of parallel lines.
Yeah. Whoops.
It's not gonna be the first, not the last time.
Yeah, I wasn't too worried. I was like, oh, okay, well, I'm gonna have that's gonna have to wait.
Yeah, so yeah, if I could actually say something very honest here, even though I'm part of this particular team, the thing that always like intimidate me a lot is like what Alex mentioned. If you want to delete a trace, like for example, you want to dig down to that trace that is like located in here, so I'm going to zoom in, and sometimes you cannot select it because it's like it's part, this sub layout here is like covering some of the area. Why you cannot actually select that blue trace? And if if you're lucky enough to select that trace, for example in here, okay, there's a portion here that did not actually like intercept both of these sub layout here. So I have like a small portion to select that. Okay, let's say you want to select this entire connection in here up to up here, right? What intimidates me a lot is like if I'm going to click here, okay, on the left panel, I'm going to see where's that trace is located. Like I'm going to open all of these nets in here. Oh my God, where are you? Like, there are hundreds of traces and nodes in here. Oh my God, it's here. And that's when I could, select the top one, which is like, let's find that one. Yeah, that's it. Okay. Then which one here? Okay, maybe like the via, like that. And that red copper that connects that via, where's that? I'm going to hover to see where's that. Okay, that's it. And then I'm going to press delete, and that will clean up that connection. That is like, to be honest, that is like the most intimidating, process which I'm dealing with every time I create like a very complex project like this. It's not so complex, but in terms of the traces that you're dealing with in here, it's very much like mind-boggling. So
I haven't gotten to a project nearly this complicated, but I have run into that particular problem or similar problem, Jarwin, where it's really difficult to get to the traces because of overlapping components or some layout. One of the things that I was thinking, I hadn't like quite got it clear in my head at the time to submit it as a feature request, but being able to select or click on the net group and have it highlight the entire net so that you can more easily locate the, so like you clicked on a single trace and then you had to open up a bunch of nets to find which one was selected. But to be able to click on or somehow highlight an entire net group would greatly simplify that.
Yep, I definitely agree on that. And by the way, this is like the most complicated kind of UX problem from the product design team. The selection. We've been working on this one very hard, and this is like our, I guess, version 0. Hopefully we could actually like get away with a solution to actually, like, we have a prototype to select something like an inner trace. Like, for example, this one here, there's a component that blocking the way for some other traces in here. There will be like a shortcut where you could press to drill down, similar to Figma. If you are aware about Figma, there's a shortcut that you could press on your keyboard, and eventually your mouse is like inside that folder, that blocks everything. So you could select this trace in here. But yeah, I definitely agree that, if you select a net, there should be like an highlight, something that will, indicate that you have selected that net, and it's very clear here on the board so that I could decide which one is which.
So as a workaround, you can just basically click, hit shift and select all the traces. So if you click the first one and then shift and the last one, you're gonna basically highlight all of them.
Yep.
But yeah, it's not as straightforward for sure, but just as a workaround, in case you find it useful.
Yep.
Is there a way to start from the chat group or the chat group? I'm looking at chat and saying what I'm looking at instead of what I'm thinking about. Is there a way to do it from the net group so you don't have to necessarily click on a single trace? So if it's buried pretty deep, can you more quickly like hover or click or somehow determine what the net group actually is from this level, from the level that Jarwin's demonstrating now?
Yeah, no, there's no way to do that right now. So that's why I mentioned that workaround. It's definitely not as handy or quick, but just it's better than just trying to go trace by trace and figure it out.
Yeah.
So that.
This is kind of mesmerizing, Jarwin.
Sorry.
I know, I sort of feel like I'm accomplishing something, even though I'm definitely not doing anything.
I plan to actually route this one live, but I actually time out myself, using a timer, and actually it took me like, I guess, 36 minutes. And okay, I'm going to do it offline, and yeah, I'm going to just show it the final one. So
one of the things that you should probably be recorded, that people find soothing watching some other people do stuff. Maybe routing PCBs is one of those things. Just record yourself routing, people just watch you with nice ambient music.
Yeah.
Wow, that's a good idea.
It's your next
Online therapy,
It's your next
Found the
YouTube
money.
channel.
Yeah.
Routing ASMR.
I would watch it.
It's your new side.
Well, I was gonna
It's
ask
a
while
hassle.
we're coming up on time. Next week, we're concluding this crash course, but we'll be online, of course, on Slack to help you if you've got questions. And Jarwin will be sharing the file, so you'll have that as a reference and can ask questions about that. And then next week, we're actually doing a deep dive. And so deep dive is what it is. It's a deep dive into a topic, problem space, basically whatever you want. And we do this between crash courses. So if you have ideas on what you'd like us to focus on, like for a whole session, just let us know. And you can let us know in Slack, in the Zoom chat. Speak up right now about the things that you'd like to learn more about. We'll also send a follow-up survey. So plenty of ways to give feedback. But other than that, I think we can wrap up the session and conclude our third crash course. So thanks so much for joining. And thanks, Jarwin, for all the hard work and putting these demos together. I thought it was great.
Well,
Yes, thanks much. It was excellent.
Yeah, thanks for attending. We'll be around. We'll
Jarwin.
stick around another, 30 minutes or so. If you guys got questions, want to hang out, talk about life, whatever it might be, we're here. Question from John saying, like, I'm not sure we actually already answered this. Is this project ready to upload to JLC PCB, or are we waiting for the airwire ground problem?
It's not really a problem, but yeah, you could actually like fork, the unrouted project link that I shared in chat, and then once you fork it, you play around, you move the component and trace them all together. Yeah, you could trace also the ground, just like a normal trace. And this is not, a board that is like, high speed data or whatever that requires, a very complex grounding system, grounding infrastructure. So yeah, you could actually like go to the, to the 2D view and just trace all of the remaining pads. I guess it's just like 1, 2, 3, 4, 5, 6. Yeah, I just left them not connected because I just want to actually like prepare for the ground feel. But yeah, just fork it and finish it over just like a normal trace, and yeah, get it published. I mean, get it manufactured to GLPCB.
You can probably also fork the one that we did for last crash course. In case you want to sort of manufacture something that is not this, I'm going to try and find the link and post it here. Yeah, if you wanted to manufacture this specific one, you'll need to finish it. But if you're just interested in getting something manufactured, you can do so with the one from last crash course that I'm going to try and find now.
I think that's the STM32, right? Just getting some STM32. What is? Oh my god.
Yeah, I figured that you might be asking for that reason. So let us find some project. Also, by the way, there's some projects in the Slack, in our Slack community chat, the one called Share Your Projects. There's some public projects that you can manufacture, get manufactured. There's some examples with like super like an LED, like a watch based made out of LEDs, like microcontroller stuff. I'm gonna just put the link to the community as well, while Jarwin looks for that specific project.
So Lance,
What's up?
hey, so when I checked yesterday, I was still having issues with the Gerber export.
Oh no. Okay. Is it the same issue or different issue?
Yeah, it looked like the same issue. My text / silk screen, whatever, is all coming out on top of each other.
Strange.
So, I mean, it's great to see Jarwin do an export today, and to see his look normal. It makes me wonder what the hell I did to my file.
Yeah, I have a suggestion, Thomas. So I guess you need to republish all of your sub layout because your project is composed of entirely sub layout, right? just publish them one by one. Maybe like republishing them, will fix the problem. But yeah, I'm going to try that one first. And I guess we're already talking in Slack, right?
Yeah,
We're direct messaging. So yeah, sorry for not responding that quickly because for the preparation of the event. But yeah, I'm going to look at your project, but I guess it's in private, so I cannot.
I fixed the link for you today.
Oh, great.
Actually the project that I've been using as my export test, the one that's coming out on top of each other, that one is not made up of sublayouts at all.
Ah.
Because
Yeah, I guess the problem was like the offsets, right? The texts are not at their proper location as well as the,
well,
I guess,
it looks like the text is all coming out on top of each other in
the same
in like the
location.
center of the board. Yeah, it's not picking up.
Hmm.
It's not.
Can we take a look?
Yeah. Well. Yeah. How?
Jarwin, can you make sure that the
Well, Jarwin
the
has
one that
the
you just shared,
images.
the unrouted one, is public?
What is the title of that project, Thomas?
Oh, I just shared it with you I just shared the link with you on Slack this morning,
Okay, let me see.
or maybe it was last night.
Okay, be here.
But it was. I'm sorry, my brain's a little fried right now.
Oh, good.
Okay, it's here.
It was something generic, I think. Yeah, there you go. Mainboard 01 generic. So that is not actually made up of sublayouts.
Oh. Hmm.
And then, yeah. So the labels for the pins and the A0 through A5, those are all kind of ending up on the center of the board when I do an export.
Okay, let's test. This is the fun part.
And I didn't know about trace space, so I've been importing into.
Oh yeah, this is the one that you're referring to, right? All of
Yeah,
the text,
exactly.
yeah.
That's what's going on.
Okay, so I guess this is clearly a bug. So
all of those pin 0 through pin 13 and pin A0 through A5 are all.
okay, so you created your own pin.
Those are all terminals, and I added a text label to each one of those.
It's nested. Oh yeah, I guess I know what's happening in here, because literally you just add this text inside the pin A1, A0, which is like in a folder on its own. I mean a node on its own, and you just added up this one here. Basically like right clicking on it and then add.
Yeah, and then
text.
add text, which is
Yeah.
what I asked you about how to do that. And that's what you said to do. So
Yeah, I thought your solution was like this. Okay, so this one is public. Okay, let me see like if I could. Okay, anyone can edit. Okay, you're sure of that. Okay, so I'm going to delete this one, A0. So pin A1 is just literally just a normal terminal, right? I'm going to right click on the layout itself, not on the node. So
okay.
layout, add, and text. Okay.
Oh, okay.
Okay, this is what I mean, by the way. So I'm going to put in it here. Let's name this one. Wait, what is that? A0, right?
A0, yeah. But it's for analog 0, because basically because I'm going to get 5 copies of this board, my thinking was to create a board that I could generically plug in other sub layouts, other boards into.
Okay, let's test this one. I just fixed that A0. Okay, come up. Okay, and then I'm going to redrag it in the trace view. I bet this one will going to work. Okay. Okay, I'm going to drag it in here. Boom.
Yeah.
A0.
Okay. Okay. So that's something I can work with. So just add the text to the
layout. Yeah.
to the
layout.
layout and not to
Yeah.
the pin, which
Yeah.
is what I.
Yeah.
Okay.
But I guess this is okay. It's just that this is something that we have not done before, or we haven't tested before, because my head is like totally like designed to be like, every time you create a primitive whatever
Mhm.
using the context menu, you need to be on the layout. There is always my thinking.
Oh,
So
okay.
what you did is actually like valid. You actually right click in here, add inside. But yeah,
Right.
the exporter wasn't able to read that correctly. But if it's
Right.
inside the layout, yeah, it's fixed. So it just literally like removing all of those text and just putting it on the layout 0, and yeah, the Gerber will be fine.
Okay, I'll do that. Thank you. That's a huge help.
Nice.
Yeah, the labels on the JST connectors, those are all working. I think from
Yep.
yeah, because that was part of the component. So